Today, I'm going to show you how to use Proteus design suite to simulate an experiment on BJT common emitter characteristics. We are going to focus on the input characteristics, and in our next tutorial, we will look at the output characteristics. These are the apparatus we require for our physical experiment, and this down here is a circuit that we are going to use to simulate using the Proteus design suite. So let's open the Proteus design suite. I'm going to use Proteus 8. So let's open on the schematic capture. Once it is open, you might want to load all the components or libraries that you are going to use to perform your simulation. Looking at the schematic diagram, you require a transistor BC107. Go to your Proteus, click on the component mode, then click on P to pick the device. Search BC107. You will see it above, then select and click OK to list it down. Go back to your schematic diagram. As you can see, you are required to have an ammeter and voltmeter. You are also required to have resistors, 100 kilo ohm resistor and a 1 kilo ohm resistor. Go to your Proteus, pick the resistors by clicking on the pick device icon, then search resistors. Select on the resistors, then in this case I'm going to pick the 1 kilo ohm resistor. I'll select it and click OK. So it is added to my list of devices that I'm going to use. Again, we are required to have two voltage sources for VBB and VCC. In this case, we are going to use a DC voltage source. Under the component mode, search for VC vSource. You will see it under the name DC voltage source. Click on it and select. You will require to vary this voltage, so you require potentiometer. Click on pick device and search for potentiometer, POTHG. Then select and click OK to add. From here, we are supposed to place the transistor on the area here. Okay, so select BC107, then go to the area, then select the place you want to place your transistor. In this case, I'm going to place it here. So that is our transistor. From our diagram, immediately you connect the voltage, one terminal of the voltage source and another terminal of the ammeter source. So in that case, I'll go to my Proteus. To pick the voltmeter, click on this icon here, and you will see a list of instruments. Select on DC ammeter and go to your area, click and join the negative terminal of the ammeter to the base of the transistor. Remember that this ammeter here will measure the voltage in microamperes because the current flowing in the base is very small. So double click on it and change the units to microamperes, then click OK. Then you have a voltage, DC voltage, select, then take it to the area, collect the positive terminal to the negative terminal of the ammeter, which is also connected to the base of transistor. So you have achieved this part. You now require this resistance of 100 kilo ohm. Go to your Proteus, back to the component mode, and pick the resistor. Then click on this area to place the resistor. Then join one terminal of the resistor to the positive terminal of the emitter. Then double click on it to change its value to 100 kilo ohm. So we have connected our resistance here. The following thing is to connect our DC voltage, which is varying. And to vary this DC voltage, we will require the use of a potentiometer. So the next thing is to select the potentiometer and place it here. Then connect the slider of the potentiometer to the other terminal of the resistor. The remaining two terminals of the potentiometer are connected to the voltage source. So select the voltage source and place it on the schematic capture. Then connect the positive terminal of the voltage source to the other terminal of the potentiometer. Then the negative terminal of the voltage source to the other terminal of the potentiometer. So in that case, we have connected our voltage source and we need to ground. We need to ground our voltmeter and also our voltage source and also the emitter. So in that case, we will connect our voltmeter to the ground and we connect our emitter to the ground. You might want to know the value of the voltage that you will be varying in the input. So in that case, you'll require to connect a voltmeter at this point. So go to this icon, click on it and select DC voltmeter. Place it here and then connect the positive terminal to the one terminal of the resistor, 100K resistor, and the negative terminal to the ground. So in that case, we have completed the connection at the input. We are now required to connect the connection at the output. Looking at the output, you will be required to measure the voltage between the between the emitter and the collector. And in that case, you will require a voltmeter. To do that, select the voltmeter and place it just here. Then connect the positive terminal of your voltmeter to the collector. Then the negative terminal to the ground. So in this case, you will be able to measure the voltage between the collector and the emitter. After that, from the circuit, you require to connect an ammeter. And in this case, the positive terminal of the ammeter is connected to the positive terminal of the voltage source, VCC. So click on the ammeter and you're supposed to reverse the terminals. Click on the X mirror, then place your ammeter in series with the collector. You are supposed to add the resistor RC as it is from the diagram, which is 1 kilo ohms. Go to the component mode and select the 1K resistor. Click on the area, then join the positive terminal to the other terminal of the resistor. From this point, you are supposed to connect the voltage source, VCC, which is variable. And in that case, you are also going to use a potentiometer just as you have done with the input voltage. So go to the components, select the potentiometer, and in this case, you'd want to X mirror it so that it faces the other side. Go to the working area and drop your potentiometer. Connect the slider to the other terminal of the resistor. And the two terminals that are left are connected to the V source, in this case, our VCC. So select your V source, place it just after the potentiometer and connect the remaining terminal to the positive and the negative terminal of the V source. You will also be interested in checking the voltage between the voltage that you are varying. So you will require a voltmeter around this area. Remember that you'll have to connect these two because all of them are grounded. So I'm going to push this a little bit to the side. So that I can add a voltmeter to measure the voltage VCC. So I'll add the voltmeter, DC voltmeter. We'll add the DC voltmeter so that we can be able to check the voltage VCC as we vary. So the circuit is complete up to that point, and we are supposed to click on run the simulation to see what happens. So let me click on the simulation. When I click on the simulation, you will see some values. So you see plus 0.5, plus 0.5, plus 0.500. So we are going to keep the value of the VCE constant. And in this case, I want to use the value of 5 volts. 5 volts. So as you can see, our voltage source here has a maximum value of 1 volt. So I'm going to double click on this. So first, I'll have to stop the simulation from running. Double click the voltage source and input a value of 5. That is the value I want to keep constant as the voltage VCE. Okay, I can choose to even use a bigger voltage source like 12 volts. Okay, so I will run the simulation again, and then I want to maintain this value VCE at 5 volts. So I'm going to slide down in order to reduce that voltage VCE to 5 volts. So I'm not getting exactly 5 volts, so I'm going to use my constant VCE value is 5.04, and I will fill this table. So in this case, I will use 5.04. That will be my VCE, and I would want to change the values of VBB as I fill the value of I'll change the value of VBB as I fill the value of VBE and IB. Notice that these ones are already filled, so I had already filled this one in the previous experiment when VCE was 0. So I want to compare the two graphs that I'll get at the end. So I'm going to change the value of VBB. So I'm going to leave the output VCE at 5, and it will remain so until the end of the simulation. So I'm going to the input, and I'm going to start at the lowest value, which is 0. So I'm going to slide down such that VBB here is 0. I will note the value of VCE and IB. So when VBB is 0, VBE is 0 and IB is negative 0.03. So I'm going to record that when VB is 0, then when VBB is 0, VB is also 0, and this one is negative 0.03, which is approximately 0. And okay, let me just leave it that way. We'll see what happens. Then I'm going to increase the value of voltage here until the current goes to positive. So I'll go to 0.2. Go to 0.2. So that is 0.2. And as you can see, I have 0.2 and 0.2 VBB, VBE, and IB still remains the same. So this one goes to 0.2. This one goes to the value remains the same, negative 0.03. So I'll move to the next value, which in this case is 0.4. So I'm going to adjust the slider here by going up to 0.4. And as you can see, VBB is 0.4, VBE still remains 0.4, and the current remains the same. So I'm going to enter this. Good. Then we will go to 0.6. So we'll change this to 0.6. And still the values goes to 0.6 while the current remains 0.03. Okay, so I'm going up again to 0.8. The current still remains the same. Let us go to 0.1. So at 0.1, if you can notice, the current at the base has gone up. So if you go to 0.1, you will get a voltage of 0.11. So you'll get a voltage of 0.11, and you will get a current of negative 0.02, which has gone higher. We will move to 0.39. So at 0.39, we have a voltage of 0.4. Sorry for that. We have a voltage of 0.4. Sorry, a voltage of 0.4 and a current of 0.02. That one still remains. Okay. Then from here, I'll move to 1. Let me just go to 1. So at 1 volts for the VBB, I get 0.67. So I get 0.67 VBE, and I get a current of 3.34. 3.34. Okay, so I'll go to 2.04. 2.04. As you can see, my slider has gone up to the maximum. So this is because the maximum voltage set here is 1 volt. So I'm going to double click on this. First, I'll have to stop running, bring the slider down so that I can change the maximum voltage of the voltage source to 12. I will be increasing this voltage to a maximum of 12 by intervals of 1. So I have changed the value of VCE. I'm going to run again and go to 2 volts for the VBB. Then I'm going to note the value of VBE and IB. So I have 2.04, which is that value. And for the VBE, I have 0.71. So this one is 0.71. And IB 13.4. 13.4. So I'm going up to 4.07. 4.07. I'm going up to 4.07. At 4.07, the voltage VBE remains at 0.71. That does not change, while the current goes up to 33.6. 33.6. At 6.11, so I'm going to change the value of VBB to 6.11. So at 6.11, I have the VBE changing to 0.72, and the current changing to 53.9. 53.9. Okay, so I'll go up to 8.02, go back up to 8.02. At 8.02, the voltage VBE still remain at 0.72, while the current rises to 73.1. So the current rises to 73.1, while the voltage remains at 0.72. Okay, so let's go to 10. At 10.1, the voltage VBE does not change, while the current goes to 93.5. So let's see at 12, which is now our last value. So 12, the VBE does not change, while the current goes to 113. So the current here goes to 113, while the voltage here does not change. So those are our full values, and we are going to use these two values to plot the graphs between IB and VBE, so that we are able to check the VI characteristics, in this case the input characteristics. Remember that the input circuit must always be forward biased, and in that case this is N, P, and the base is P, and if you follow, you'll find that the base P is connected to positive, while N is connected to negative. At the output side, it must always be in reverse biased. So remember, this is positive and it goes to N, negative terminal. So this one is reverse biased. So I want to check the values. We want to plot these values and check the nature of the graph. Okay, so I have the values here. Okay, I have the values here. Remember that VBE values are the same. So I'm just going to use one value when plotting the value at the x-axis. And we are going to check the variations in VBE versus the IB. VBE versus the IB. So I want to copy this and put it in an Excel. Let me put it in an Excel. So I'm going to delete this. So these are our values that we are required to plot. Okay, so I'm going to save this, and I'm going to use the IBM SPSS to check the graph. Okay, so I'm going to open the IPSS for statistics. I'm going to import this as data. I'm going to select the Excel and select the file which contains the data, and I'm going to open this, and the data will be loaded. The data will be loaded, and from this area you can see. All I need to do right now is just press OK. Just press OK. So as you can see, all my values have been loaded in here, and I want to compare the currents. What happens is the currents move. What happens as you increase VBE? What happens to the currents? So I have my values here. I'll go to graphs, go to legacy dialogues, and then I'm going to select line. In this case, I want to use multiple line graphs. I'm going to select multiple, and values, select values of individual classes, define. So at this point, this is where I'll select my variables. So I'm going to select the two currents. Those are the variables I'm interested in. And then I'll keep one of the VBE. Okay, I'm going to keep one of the VBE. Let me keep this one. So I'm going to put this one as a variable too. And from that case, all I need right now is to check for the title. And the title in this case will be BJT CE input characteristics. And in this case, I'll click continue and click OK. Okay, so you'll see we have two lines which are almost close to each other, because we have the blue line and you have the red line. So as you can see, there are two lines, and these lines represent the current IB. So I'm going to copy this and paste it here in the Word document. So this is the relationship between the value. This value here stands for the current, and VBE stands for the voltage between the emitter and the base. And you can see this is how the graphs will look like. So this is how to use Proteus software to simulate the common emitter characteristics at the input. Don't forget to check on my next video. This video will be looking at the output characteristics, and we will be able to also use the Proteus and IBM SPSS to compare the characteristic curves. Thank you. Remember to subscribe, and see you in the next